Okay, so we're in chapter 10 now, and we're going to work on what's called conic sections. And essentially the idea is, if you have two cones, you all know what they look like. Say like this and like this. We want to look at the things you get when you intersect the flat plane with those cones right there. Essentially, if the plane I intersect is straight across like this, if you think about the circular cone, if I cut right across it, I'll end up getting a circle. We've already worked with circles in the past. If I cut at an angle like this, well then the circle I get when I cut that way will be elongated, and it'll actually be what's called an ellipse, more like that. There's a few other possibilities. You could cut through it this way right here, and then again, if you see the cone like this, if I cut this way across it, well, I'll actually get something that looks like that. It's a parabola. We've worked with those in the past. We'll expand on them this time too. And then in theory, the plane could cut across both of them like this, and then essentially I would get something that looks like that and like that. Again, kind of like a parabola, but there's two of them. We're going to look at each of these cases here, not really the circles, because we've done those before, but these things called ellipses, the parabolas, and these are called hyperbolas. We're going to look at each of those, mess around with them, and kind of see what's going on and algebraically how to deal with them. Okay, in this video, we're going to look at the ellipses. By definition, this is in your book, an ellipse is all points in the plane whose sum between two fixed points is the same. Essentially, the idea, because it's important, so I want to make sure we understand it. Suppose we have my plane right there, and I have an ellipse. It's kind of like an elongated circle. When you have your ellipse, you have 2 points on the inside right here, 2 fixed points. They're actually what's called foci. One of them is called a focus. That's a focus, combined plural is foci. But essentially, if you pick any point on the ellipse, say this point right here, if you find the distance between that point and this focus, and this point and that focus, if you add up those two values, those two distances, then that sum is the same as it would be for any other point on the ellipse. So say you pick this point. If you find the distance from this point to that focus and this point to that focus and add them up, this sum is the same as that sum. It's true for any point on the ellipse. The sum of the distances from the foci to that point is the same for all of them. But once we kind of understand that, and we'll use it a little bit more as we mess around with these things, there's kind of a lot of key points for our ellipse. So we draw it again. We'll have our 2 foci right here. In your book's terminology, if that's the origin, your foci are labeled C. So that's C0, that's negative C0. Then you have what's called the major arc. This ellipse can be oriented horizontally like this, or you can turn it and orient it vertically. For a horizontal one, the major arc is just the longest arc, which goes through the 2 foci in the center. Your book labels the major arcs A, so this is the point A0, this is the point negative A0. And then, if you go vertically, this is the minor arc, this is the point 0B, that's the point 0 negative B. As far as solving these problems out and working with these ellipses, these points are important. Being able to find our center, being able to find the foci, the major arc and the minor arc, and again, we'll use these letters, A for the major arc, B for the minor arc, C for the foci. It's the tradition, the way we kind of write these things out, and we'll do it to avoid confusion. As far as it goes, for my equation of an ellipse, we do this. X squared over a squared plus y squared over b squared equals 1. Or your book will give another equation, y squared over a squared plus x squared over b squared equals 1 right there. Ultimately, it doesn't really matter as long as you understand what's going on. Basically, A is the major arc, B is the minor arc. Wherever the A is, whether it's under X or Y, that tells you the orientation of your ellipse. Here it's under the X, which means my major arc is in the X direction, it's horizontal. Here it's under the Y, so my ellipse would be oriented vertically. It doesn't matter how you actually write them, whether you want to put the X first or the Y first, as long as you understand the bigger number tells you your orientation. Ultimately, you can manipulate these. I'm not going to go into great detail beyond maybe solving a problem on this, but essentially, well, if this is a regular ellipse centered at the origin, you could expand on this and do x minus h squared over a squared plus y minus k squared over b squared equals 1. That's still just an ellipse oriented horizontally because the A is under the X, but all of you know from 171, I can transform my graph, move it around. This one, the center would be moved by H and by K. So we can take this basic ellipse and move it all around. But before we actually look at problems, there's a lot of algebra involved with this. I'm not going to do all of it, but we can do some of it. The question becomes, like, how can I relate some of these quantities? And one thing we can do is, well, we'll just keep drawing our ellipses. Let's see, that's C0. This is A0. That's negative C0. That's negative A0. And now, by definition, the ellipse is all the points in the plane, the sum of whose distance, if you take the sum of the distances from the two fixed points, the foci, to any point, it's always the same. So now we're going to manipulate that a little bit, but we're going to pick a particular point. I'm going to use A0. Now by definition, the distance from this point to the two foci, so the distance to that foci and the distance to that foci, has to be the same from any other point on the ellipse. So now find that distance. This distance is easy enough. If that's C and this is A, this distance is A minus C. This distance right here, this part of it is A, this part of it is C, so that's A plus C. Again, I know this is negative, but we're just looking for the distance which is positive. That's a distance C, that's a distance A, so that's A plus C. If we add these together, the C's will cancel and we get 2A. Which means the length of the major arc from one side to the other is 2A. So if our major arc was 12, well, I guess that would tell me the A is 6. And, well, it also tells me that since the distance between any point and the two foci, the sum of the distances added up, is constant, it means if you pick this point, the distance from this point to that focus and that focus added up also has to be 2A. So this is just kind of a nice little trick we can use to help us solve problems. As far as it goes, there is one other algebraic representation that we need. And I'm not going to do the workout. Your book mentions it, and it actually works through it in one of the homework problems. It's long and involved, and it would take most of the 15 minutes of my video on YouTube, so I'm not going to do it. You can kind of work through it, but essentially we get a Pythagorean type identity, but it's not the Pythagorean identity. It says that b squared equals a squared minus c squared. Keep in mind, we all know the Pythagorean identity, Pythagorean theorem, a squared plus b squared equals c squared. This is not that. It's the same principle, but it's not that, because this is a difference, not a sum, and if I get the a and the b on one side, it's not a squared plus b squared, it's b squared minus a squared. So just be aware of that. It looks like the Pythagorean identity, but it's not. We'll actually see one later on for another conic section where that comes into play, so we have to keep this straight. You can derive this on your own. It's all in your book step by step. I'm just not going to do it because it takes too long. But essentially, given this information and that information, we want to be able to completely classify and work with and graph ellipses. So we'll do that. We'll maybe do one quickly, and then I'll make another video doing a couple more. So, first off, suppose I tell you I have an ellipse centered at the origin. 2A, the major arc, is equal to 20. And the foci are at, one of the foci is at 3, 0. So a focus is at 3, 0. Graph the ellipse. Find the equation. Well, let's see. We know the equation is x squared over a squared plus y squared over b squared equals 1. And now we fill in. If we look at the graph, let's see. We know the focus is centered at the origin, so the center is going to be here. I'll use the black one for that. The center is going to be here, and I have a focus at 3, 0. Given that the foci are equidistant from the center, it means the other focus has to be over here at negative 3, 0. But we also know the major arc is along the direction of the foci, which means this ellipse definitely has to be horizontal. It's not going to be on to scale because of the whiteboard. But we also know the 2A is equal to 20. We said 2A is the length of the major arc. A is half of that, which means A is 10. Which means this is the point 10, 0. That we already said was 3, 0. That's negative 3, 0. That's negative 10, 0. In terms of my equation up here, I need a squared. We just said a was 10, so a squared is 100. Now to get my equation, and to maybe finish my graph, I just need to find b squared. But we have that identity. B squared equals a squared minus c squared. So b squared equals a squared, which is 100, minus c squared. C is 3, so c squared is 9. So b squared equals 100 minus 9, 91. So b is the square root of 91, which is just some messed up number. So here, this would be the point 0, root 91. This would be the point 0, negative root 91. And then up here, if b is root 91, b squared is 91. And there's my equation of my ellipse right there. I'm going to make another video doing a few more examples of this, because there are different ways we can manipulate these, and I want to do a lot of the algebra out so you can kind of see how it all works.